All right, let's continue to look at our exponent laws with negative and zero exponents. A couple of things to remember: when we have the negative exponents, we use a reciprocal. And when we have zero exponents, they always have a value of 1. So let's look a little bit closer at this. Again, here are those exponent laws. You may want to screenshot this or copy this down somewhere. Again, this is from your math chart. If you Google EOC, algebra chart, you can even find it online, and you can get it available. You could print it or whatever so you can have access to it. And there's other information too. All right, here we go. So we're going to decide if the value of each of these expressions is positive or negative. So you could obviously use Desmos in this case, but I'm going to kind of talk us through this. If I have a negative 2 squared, the negative is hanging out front. So this is like saying negative 2 squared. So this would mean that this would be negative 4. So this would actually be a negative solution. For the next one, we have negative 2 times negative 2 times negative 2. Sorry, that's messy. But think of it this way. When you have a negative times a negative, this is a positive. But then if you throw in another negative, that's going to create a negative solution. So in this case, this would be negative also. For number 12, I know they're kind of numbered funky, but for number 12, that's a negative times a negative. It's only 2 times. So in this case, this one would be a positive. For number 14, it is just like number 13. The only exception is that whatever your solution is going to drop down to the denominator. So this would be negative 2 to the 3rd power. It is an odd exponent, so that means it would be a negative product. All right, so now we're going to write each power of 10 using negative exponents. So the first thing I'm going to do is talk about our powers of 10. Remember, we have 10, 100, 1,000, 10,000, and so on. So these are all the values we're going to be looking at today. Remember, a power of 10, like for example, this one here would be 10 to the 1st power. This one would be 10 to the 2nd, 10 to the 3rd, and then 10 to the 4th. So that's what we're going to be using. So if I have 1 over 10, that would be 10 to the 1st power, but because I want to eliminate the fraction, this would actually be 10 to the negative 1. For number 16, it would be 1 over 10 squared, but I want to use negative exponents. So this would actually be 10 to the negative 2. So keep in mind, when you have a negative exponent, that doesn't change the value positive or negative. It's just whether or not it's a fraction or it's reciprocal. So if I have 10 to 1,000, this would be 1 over 10 cubed, or 10 to the negative 3rd, or negative 3. This one would be 1 over 10 to the 4th, so it would become 10 to the negative 4. All right, so we're going to complete this pattern using the power of 5. I think we're going to actually expand this out, and I'm going to write it below so that I have a little bit more space. So 1 over 5 squared would become 1 over 25. 1 over 5 to the 1st would be 1 over 5. 1 over 5 to the 0 would be 1 over 1, or just 1. So remember, this is 1 over 1 because it's 5 to the 0 power. Then here I have 1 over 5 to the negative 1. So this would actually become a whole number. I'm going to flip it over. So this would be 5 to the 1st over 1. So then it would just be 5. This would become 5 squared over 1. So this would become 25. So if you notice, there is a little bit of a pattern here to get us through.